And we're live. That was a radio voice, wasn't it?
Yeah, I mean, you got the makings for a radio co-host.
How's everyone doing, guys?
Doing all right. Doing all right.
I can't hear you.
Can't hear me. Oh, that's not good.
I can hear you.
I can't hear you. Can anyone hear me?
I can hear you. I can hear Marino.
You can hear me?
I can hear everybody.
Oh, okay. I can't hear you guys, but that's a problem with me. Anyway, Marino, I'll let you drive if you hear me. So
Yeah,
feel free to
for sure.
go ahead, and I'll fix my stuff.
Awesome. All right. Welcome, everyone. Today, we are covering day 3 of that Istio Certified Associate exam. So we're going to cover off things around microservice resiliency and working with capabilities around fault injection, circuit breaking, and using timeouts to control how the flow of traffic works inside of a mesh, and especially when we have requests flowing between multiple services in path. But before we get into that, let's quickly recap some of the stuff we covered yesterday, because that's critically important for understanding how we work with the tools inside of resiliency for Istio. Now, before I continue, Alessandro, I know you can hear me, but I just want to make sure that the audio is coming across into YouTube, and I don't have the YouTube channel open, so
let me check. Let me double check that, and then
Excellent. So, how is everyone doing? Where is everyone coming in from? I'm actually based just outside of Toronto in Canada. I'm in a place that's it's about half an hour-ish east of Toronto, and so it's nice. I live in the suburbs, pretty close to the water, so it's nice to be. Okay, I got the thumbs up from Alessandro, so that means I can stop my unnecessary spiel about things that are unrelated and get right to it. Okay, so let's do a quick recap and talk a little bit about some of the technology and concepts that we discussed yesterday. So in our mesh, in our service mesh, we have a couple of key artifacts and resources. We have the ingress and the egress gateway. Now, you can think of the ingress and the egress gateways as our entry point into the mesh, and our egress gateway as our exit point of the mesh. So our ingress controls traffic inbound. So anyone that's trying to communicate from the outside towards services inside of the mesh, we can control that through the ingress gateway, and we can create some configurations and definitions for that. Whereas if we're trying to filter traffic on the outbound, we're trying to control what our internal resources can communicate with outside. That's where the egress gateway can come in. Then we have sidecar resources. So the sidecar resources are deployed as secondary containers inside of your application pod or your main application pod, where it sits alongside the main application container, and it's in path of that container. So it's proxying all the connections for that container on behalf of it. It's managing certificates, it's processing policy, and so forth. So that's what we use the sidecars for. And, for just a side tangent there, oops, I think I went a little bit ahead there. Just a side tangent. Now, in the case of ambient mesh, some of you might have heard about this new mode of service mesh called ambient mesh. It's a sidecarless model. Now, the sidecarless model or ambient mesh isn't inside of this exam per se, so you don't have to sit there and think about how to deploy it or how to work with it or how to communicate with sidecar resources versus non-sidecar. But go check out the documentation and you can take a look at how ambient mesh works. Now, there's another resource here called the virtual services resource. This is where we define the mapping of how we communicate from the outside world or between our services to our actual services. And it sounds a little janky, but think of it this way. So if I am a client that's trying to ingress into your mesh, right now the ingress gateway will accept that request and it has to direct it somewhere. So in order to direct it somewhere, it's going to use a host name, and that host name is going to be associated with a backend Kubernetes native service. But in order to create that association, we have this virtual services resource that creates that mapping for us. So as long as we define what that host is, that host address, which is a DNS address, and map it to the backend Kubernetes service, now we have a linkage there. Now we know how to route to that service. I'll show you a diagram in a second. Then we have destination rules. So you can think of destination rules as a mechanism to apply policy when traffic arrives at that destination. So what should we do to that traffic? Should we direct it to that primary version, a secondary version? Are we leveraging TLS? Several capabilities are built into the destination rule, and we'll explore that as we're configuring some of the resiliency features. And then we have something called service entries. So service entries are used when we want to define explicit DNS records for where we are trying to get to, a destination, for example. So you would manipulate the Istio configuration and specify something, which is I can't remember what it is, but you're basically saying if you're going mesh external, you have to define something in the registry only field. I'll go back and pull that up in the docs. But when you have registry only turned on, that means you have to manually define service entries for any sort of traffic exiting the mesh for direction towards a particular destination. Now, there are some capabilities that are granted with virtual services and destination rules. For example, you could do request routing, where you can decide how you want to send your traffic based off of header information. So for example, if I'm just sending straight up curls to a service, I'll go to a particular version by default. But if I append or add some header information into my request, as long as that header information matches something in my virtual services configuration, it'll route me to another version or another instance or something different because of that header information that's there. And then with respect to traffic shifting, you might use these in scenarios where you're trying to do like a blue-green or a canary deployment where you have maybe traffic going to an initial version of your application and you're trying to shift traffic over to another version. So you're playing with weights. Now, in real world production, you're not going to sit there and modify YAML configuration to adjust those weights every single time. There are tools like Flagger or additional CI/CD tools that'll help with that. And the last thing that was discussed yesterday is mirroring. And I'll show you some of these examples shortly. Mirroring is the situation where you can actually mirror your requests to another resource, a secondary resource, a duplicate resource. We'll see that in a second. And that might be used in instances where you're trying to capture some telemetry to understand how requests are behaving or how responses are being sent back, or to discern if you need to scale the resource up or other things too. Let's take a quick look at the diagram so you can see just the general flow of traffic. So in this diagram, this is a great diagram that's in the Istio docs. Peter found it for us, and I'm going to use it just to explain not the TLS portion of it, but just the general flow of traffic. So as I mentioned, you're going to receive traffic on the ingress. So you have this little artifact here, which is our Istio ingress gateway. So it's listening in on a specific host name, maybe on a specific port. And when it receives those requests, it's going to direct it towards a particular service based off of the virtual service configuration that we provided. So let's just say in our virtual service, it says, based off of this gateway, we're going to route it to service A. We'll do as such, and service A will return some response to the client, and we're all good. But we can also have virtual service configurations that say service A can talk to service B or route to service B, capture some more telemetry or some more data or process that data, take it back to service A, and then feed back some data over to the client. Now, if you're seeing the service A here and then service B, this is the association to a Kubernetes-based service, like a Kubernetes native service. So you know how when you're exposing a deployment or a pod, you have a few types of services. You'll have load balancer, you'll have cluster IP, you'll have node port. In the case of using something like Istio, you would have all of your services bound to cluster IP because you wouldn't directly expose them using the load balancer service. You would use the Istio ingress gateway to be able to get to them. So it's a good mechanism to control the flow of traffic, provide some policy, even implement TLS here so that your connections are secure inbound. Also, if you look to the very far right, that's our egress gateway. So you can assume that if traffic has to exit the mesh, and if you have an egress gateway deployed, traffic will be routed through this egress gateway, and you would have to provide some additional configurations here to just control what's going through that egress gateway. I'll pause for a second. Peter, Alessandro, any comments, thoughts you want to add?
One thing that you mentioned when you were talking about load balancer services, right, and all that, ingress, when you deploy it, Istio Ingress Gateway, right, when it gets deployed with Istio, is actually a load balancer service as well, right? But it's just a way to have one place, right, one spot where all your traffic comes in. You could theoretically, if you have service A, service B, service C, you could expose all those as, or create all those as load balancer services, but that wouldn't make sense, right? You wouldn't have external IP. You don't need an external IP address and a load balancer for each one of those. So you just do ingress, one entry point, and then you configure everything there, right?
Exactly. Yeah, that's something I'll share in a second when I pull up my terminal. Sorry, go ahead, Alessandro.
Just this always confused me. So it's an ingress, as in it does the function of letting traffic in, but it doesn't really care or obey or take care of the ingress resources. So when you use service mesh, there is no ingress resource that you need, right? So it's all virtual services, gateway. So, and as we touched a little upon yesterday, and it's not part of the certification, not part of the example. There's a gateway API incoming on the horizon, and it works the same. So even when you use gateway API, you do create these ingress gateways, just that you don't deploy them when you deploy the service mesh, when you install Istio, but Istio will deploy them on demand when you create a gateway API kind of resource. So I'm planning, actually, this in my to-do list, to do a gateway API series or a blog post. So it's important because it's coming up.
Yeah. The thing that you brought up about when we talk about Istio, there's so many terms and there's so many overlap between these terms. Istio Ingress Gateway and Istio Egress Gateways, a gateway, when I personally talk about those things, I'm thinking of an Envoy instance that can be configured with an Istio gateway resource. Now, there's also something called ingress resource in Kubernetes that is also can be used to configure a ingress controller, and that controller can be an Envoy proxy, it can be an ingress gateway pod, right, or it can be Nginx. And then there's the third thing that you talked about yesterday, Alessandro, the gateway API, which is something coming from Kubernetes again that will allow you to configure Istio Ingress Gateway. I think there's a diagram somewhere here in what I said, or a Venn diagram or something.
Yeah, if you do come across that diagram, let me know. I'll bring it up. But yeah, that's actually a great point that you bring this up around the Istio Ingress Gateway. You can actually deploy a regular Kubernetes-based ingress as long as you have the right annotation to say we're using the Istio Gateway class. Then you're able to actually consume Istio's Ingress Gateway for the Kubernetes ingress. But the reality is, if you're using Kubernetes ingress, you're pretty limited in functionality. So this is why we push you towards using the Istio Ingress Gateway. Okay, so let's get into some demo environments here. I will say that I've already got Istio up and running. I've already installed it, deployed a sample application. By the way, if you actually do download Istio through the website, there's a directory here that has all of the applications and sample configurations. So we'll take a look at them. You don't have to sit there and manually build this out yourself, but I will actually go through the tasks as well, so you can see the configurations live and where you could copy and paste from if you were in the exam. So I've got everything deployed. We'll take a quick look at our cluster. And Peter, Alessandro, how does the font look? Should I make it a little bit bigger?
Yeah, make it a little bit bigger, just
Okay.
in case. I can switch back to a different layout then, and then the website as well, just a little bit. We are 1080p, so it should be easier to read, but still.
Yeah, I don't
Yeah.
need this website to be massive. So there we go. Better?
Yeah, I think so. And people on YouTube, if you're all right, or if complain, that's what I'm trying to say.
Exactly. Okay, so I'm just going to take this simple YAML configuration here because I just want us to review it quickly. So this is a gateway configuration along with a virtual service configuration. So what's going on here is we've given it a name, pretty straightforward. We've got a selector here. And the selector is just basically telling us, let's use the Istio Ingress Gateway as long as it has the label Istio equals Ingress Gateway. And this would be located in the Istio system namespace as a pod resource that's exposed as a load balancer type. Now, what we're doing is we're actually listening in for connection requests on HTTP, basically, on port 8080 for any host. So we haven't specified or defined a specific host, but as long as we're receiving requests, say, to a local address like 127.0.0.1, it'll route to the service itself that we're trying to get to. Now, here's the virtual service configuration, or more so the routing rules or the routing pairings. I'm going to move this water bottle here because it's actually blocking my screen. Oh, by the way, I have this big TV that I use as a monitor, so excuse me if I keep looking up. I actually have to on occasion because of how big this thing is. Anyways.
That's a humble brag.
Yeah.
Sorry, I have a big TV and
no.
I have to look like this.
My neck hurts. I have to go see a chiro at some point. Anyways, so we got this virtual service configuration. Book info is the name of it. And the association here, this gateway tab or this gateway field here associates this virtual service directly to this Istio Ingress gateway that we created up above, or the resource that we created right here. Meaning, as we're listening in to requests, we're going to use this virtual service. We're going to pair it with this virtual service and now know where to route those requests to. So we've received a request on the book info gateway, and it could be any one of these paths. As long as we have one of these paths, what we'll do is we'll route to the product page service. So the product page service, if we do a kubectl get svc, is a service that exists in this cluster because we have all the applications deployed. So if I do a kubectl get deploy, we see we have several different deployments, and we can also see all the different pods that are deployed as well. Now, notice here there are 2 out of 2 containers in each pod. All that means is the namespace has been labeled with the istio-injection equals enabled label. And that means that when I rolled out these services, they all had the sidecar injected into them. So the proxy is in effect, or the sidecar proxy is available. If I really wanted to, I can start doing other things like turning on TLS and peer authentication, but we're not going to cover that today because Peter's covering that tomorrow. But what I just wanted to illustrate that the sidecar exists, it's there, and we can do things and program it as accordingly. But we're not going to get that far right now. We'll explore that later on in our session. So we have everything running. We're able to see that we have a gateway deployed, which we can verify here with a kubectl get gateway. It's there. And if we do a kubectl get VS or virtual service, which is what VS is short for, we can see that we have a number of virtual services. But the one we most notably care about is this one right here, because that's our initial entry point. So in my situation, I'm using a Minikube cluster. So if I do a kubectl get nodes, I have 2 worker nodes and 1 control plane node. Now, in order for me to obtain a load balancer service for the Istio Ingress gateway, if you look here, the load balancer type, and then it's got an internal cluster IP, and it's got an external IP of 127.0.0.1. that just means that I've just used my local host to expose this Istio Ingress gateway. So I should be able to access anything behind it that I've configured the gateway to do so. So in that situation, everything is good. I had to do this by going over to another tab or another terminal. And if you can see here, I ran the command minikube tunnel. Minikube tunnel just simply enables your services in Kubernetes to get a load balancer IP. So I bring this up because if you're running, let's say, an M1 Mac and you're using Kind, for example, and you're using Metal LB for load balancer services, there's some hacks that you actually have to do, and it takes a little bit of work to actually get up and running so that your local system can curl to the load balancer IP that Metal LB issues your services in Kubernetes, specifically the Istio Ingress gateway in our case. I think Alessandro has a repo that he can share that might help you if you're trying to just do this all in Kind. I'm just also bringing this up because you can equally do everything that we're doing over the next 5 days and the last couple of days with Minikube as well.
Yeah. It's the only differences between these things is how you expose the services, how the load balancer service gets exposed. That's it.
Exactly.
Everything else is exactly the same.
So if I do a curl right now and I type in product page, I'll get a response, or I should get a response. And it's basically telling me that product page is accessible. It's a simple bookstore, and that's good. We can even see it here on the website. So it's loading. I mean, well, it's already loaded because it's been cached. But if I just, or actually just go to a new page, even, we're good to go. So there might be an error for catching reviews. Maybe I just haven't configured the virtual service for that, but that's okay. We'll update this as we go along so that we can access everything. All right. So we effectively do have an ingress gateway deployed. We have a virtual service configuration that routes us to the product page or the book info app. So we're able to access it and see what's going on. So at this point, like, we've covered some key elements here, right? Just how to get access or traffic into our cluster. What we're going to do now is we're actually going to go over to the traffic shifting section. So we'll have several instances of a particular service, several versions, I should say. In this case, it's reviews v1, v2, and v3 that will be present in our environment. And we're going to manually shift traffic over to one of the other versions. So you can follow along too if you have a Kind cluster up and running, or you have Minikube up and running as well. But let's take a quick peek at this configuration so you see what's going on. So as I mentioned, as long as you're in the Istio-1.19.1 folder or directory, you should be able to just access this directly without any issues. So what we have here is we have 4 different virtual service configurations. All they're saying is, how do we get to each one of these services? If the host is product page, well, the Kubernetes service is product page. But also notice that there's a subset here. Now, if you were on our session yesterday, you probably would have noticed what a subset is. We would have taught you that, but just as a reminder. So we actually have this destination rule file called out. It's configured, it's actually deployed. And that destination rule configuration basically maps to the different versions of product page. So I might have version 1 of product page and version 2 of product page, and I've aligned that to a subset. This subset v1 just calls on that specific version that I'm trying to reference. So if I'm trying to reference v1, then I would go to product page v1 based off of that definition in the destination rule configuration. So you have a very similar format for some of the other services like ratings, reviews, and even details. Let's go ahead and apply this. I think it already is applied, so it should say unchanged, which is okay. And we're also going to just check something. We'll see if we have a DR, a destination rule configured. And we do. We have a bunch configured. I'm going to pick on one quickly. Let's pick on reviews. So I'm going to type in kubectl get dr reviews -o YAML. You can ignore all this stuff here for now. What I care about is what's under the spec. So if we look under the spec, host is reviews. So we know we're going to the reviews service. But if you look at this, we have 3 different subsets here. I have one label here, v1, which is basically named as v1. So this is the reference, or this is the tieback, v1 here, to this v1 subset. So this is the linkage that I'm referring to here. Now, what this label here is doing, you see this label, this is a label selector, which is going to look at any sort of workloads, I should say. So if I did a kubectl get pods -- show labels, it looks a little dirty and messy. But if you see the review service down here, right, this reviews v1 has a label version equals v1. Oh, very similar to this, right? This version v2, right, for reviews v2 is associated with this. And then we notice the same for version 3. So that's the linkage right there. So without this destination rule configuration, I would always, and if I didn't have this subset configuration, I would always route to the single details pod. And that's a problem because we have 3, or sorry, not details, I'm talking about reviews, I should say. That's a problem because we want to be able to choose which one we want to go to or which version we want to go to. So there are a few ways we can control this and how we go about going to each one of these versions. So we're going to modify the virtual services configuration for reviews, and we're basically going to split the traffic. So half our requests will go to the version v1, the other half are going to go to version v3. Before I even do that, I feel like I should do a quick curl. Actually, maybe I don't need to do a curl. Let me just do a quick echo. I just want to see what my gateway URL is. Oh, dang. I should probably type in gateway. There we go. Okay, so it's there. Cool. So if I copy this in, right, curl, and then I just grep for v1. Let's see what it comes up with. Okay. So it's telling me that I am going to reviews v1. That's exactly what I expected to do. We're going to shift this traffic, and I'm very, very bad at like using for loops in curl. So I'm just going to use the web browser and show you all how it shifts and does a bunch of things. But let's go ahead and apply this. Actually, it already is applied, so it should say unchanged. So it's all good there. Let's go ahead and apply this v3 one. And, this is the config, but we'll just take a look at it from the terminal so it looks a lot larger. So, as I was saying, right, now that we've updated our virtual services configuration, or our quote-unquote routing configuration, half of our requests are going to v1, the other half are going to v2. So if I go over to my web browser here, and if I refresh a few times, notice that reviews is served by reviews v3 pod. And I know this because it's popping out the red stars, or the red rating. If I refresh again, I'm not getting any sort of stars, but I know that I'm going to v1. If I refresh again, refresh, 50-50 is exactly what I wanted as a configuration, and I got exactly that. Okay, we're a half hour in. I'm going to try and speed this up a little bit so we know traffic shifting is working. Let me just go back to that tab somewhere here. So we're all good there. Now, if we really wanted to, we could shift everything to 100%, but you all get the picture. I don't need to show you that if I change this to 100%, everything should go to version 3. But believe me, I'm not lying to you. If I changed it to 100 and left the weight off subset v1, everything would go to version 3. So what we're going to do now is we're just going to remove what we created here so that we can just do the traffic shifting lab next. Sorry, not traffic shifting, the request routing. And then what we'll do is we'll do traffic mirroring quickly, and then we'll move on to some of the resiliency features. So, Peter, Alessandro, anything to add before I continue on?
No, not really. One of the I wrote a couple of tweets yesterday after the session. One of is the relation between subsets and how it is in Envoy, right? It's just if you would run, once you had the subsets deployed or the destination rule deployed, if you would run Istio, like Istio-CTL proxy config, pod name, clusters, you would actually see that there's a separate cluster, Envoy cluster we're talking about here, created for each subset, right? So reviews V1 has its own cluster with its own endpoints. V2 has its own cluster with its own endpoints. And that's how internally or behind the scenes, the actual traffic shift in between the two, 3 or more destinations happens, right? So, but yeah, nothing new to add, I guess. Yeah, one thing on this Ubuntu 20, that doesn't necessarily, you don't have to practice on Ubuntu, I guess, unless you're like on Windows and that's the only thing you're used to. But there shouldn't be any difference in how like the clusters in the certifications are deployed versus what you can deploy for practice, right?
Exactly. Yeah. So the OS is at this point unless you're using a really old version of Ubuntu, then it could be problematic for you when trying to get like Docker up and running or something like that.
Yeah.
But yeah, if you use a more recent version, you should be fine. Configs and how Kubernetes works doesn't really change drastically across like 2004 and I think we're at 22 right now, Ubuntu 20 or 21, one of the two. Anyways, you're fine regardless. I'd just say if you can spin up a multipass VM on your local system and deploy everything on it, like Docker kind, and then whatever else you need, like Istio, that should be more than adequate. Okay, so getting back to it, and what I'd like to do is actually get through this stuff, take a quick, bio break, because I don't want to get into the details, but maybe pass the ball to Peter for a couple of minutes while I run off after I've gotten through this, and then we'll come back and do fault injection and resiliency. But all right, so we've got a virtual service configuration deployed. Everything is routing to V1, version 1 of all of these different services that exist. We've already seen the destination rules, so I don't need to review all of that with you, but you can notice that some of them only have a single version, while others might have multiple versions. There's even one that has one V2 MySQL. I'm not sure what that is. It's not covered today. We won't have to go into detail here. But here's the reviews one that we just looked at. 1, 2, and 3 for the versions. Okay, so I don't need to test because I know this should all work, but I'll just do a quick refresh here. And we know everything is going to go to version 1 because that's all we've configured it to do. So if I go over to routing by user identity, this is where I can pass in header information in my request, or I can log in with a specific user and get a different result. So let's copy this YAML over and paste it here. And let's also take a look at what that YAML is outputting. So if we look at this YAML configuration, it's another virtual service configuration, again, routing to our resources. But let's look at the specific match. And I think what also will be highly relevant and important is the indentation here, which is why sometimes YAML gets screwed up and it doesn't always work. But pay attention to the indentation here. So we're going to the review service. We know this. And we have an HTTP definition. But if you notice, look at the alignment of this match statement and this route statement. And then if you notice, this route statement actually is indented. So what has to happen is we're going to assess and see if there is a user named Jason that is trying to access the service. If that's true, well, we're going to route them to version 2. If else, meaning the request is a standard request, no special headers, Jason is not there, we go to V1. So it's already been applied. Now, if I go here and if I, refresh my screen, I'm not logged in. I still keep going to V1. But if I click sign in and I type in JSON, I really think we should change this to JSON, like, JSON. I feel like there's a tongue-in-cheek joke there. But notice here, we're going to V2 now. So we're hitting up V2, and that's specifically because we're JSON. If I sign out again, it's still V1. So that's request routing. We're going to just delete everything here and unchange everything or revert everything back to its original state. But the point of this specific lab is, let's just say, for example, in real world, in production, maybe you want to gate access to another version, a newer version of your technology to a subset of users. This is a very specific example of how you would do it, but there are other methods that you can use to be able to just route those specific users directly to that service. So I don't know, maybe Alessandro or Peter, if you want to describe how we would do that.
Yeah, this one would be very like an extremely simplistic way, probably not too secure either, right? But like if you really wanted to do routing based on the user that's logged in, like realistically, right, you would probably use the JOT token, right? The user would sign in, it would go through the token service identity provider, get back the JOT token, and then there are resources in Istio that you could use to configure, right, and pass that token through the services as part of the request, and verify that the token is signed correctly, it is issued correctly, and then you can also use policies to apply against the claims from that token, right? So you would realistically say, if the token is valid, and if the claim in the token, if the username claim in the token equals JSON, then yes, this request can access the service, right? That would be like a proper way to do the user stuff, and I can talk about a little bit about this tomorrow during the security section.
Love it. Awesome. Okay, so what we're going to do in this particular module or this particular demo is we want to mirror our traffic. So the requests that go to one version should also be mirrored to go to a second version. We're not going to use the book info app. We're just going to deploy some HTTP bin applications, and we're just going to check and capture the logs as kind of denoted here so that we can review the logs and see the requests coming inbound. So there's two versions we'll deploy. We'll deploy the first one here. Nothing special about this, like it's using this particular image, HTTP bin. It's got some labels associated with it, version v1, so we can denote that it's a v1 instance. And then we have the same thing for a second HTTP bin, which is version 2. Nothing special there. And then we're going to just expose our service here. And what this is going to do is just create a cluster IP. When you're defining services, if you don't define the type of service it's going to be, it'll default to cluster IP at all times. So we're going to start another service called the sleep service, because we're going to use this to curl in and effectively just communicate with both HTTP bin instances. What that means is I'm using this curl client to basically send traffic to these instances. That's all it's really doing. All right, so we've got these 3 different pods deployed, and they probably have sidecars. Yeah, they probably have sidecars. That's irrelevant because I haven't done any sort of specific tuning or configuration to the sidecars. They're just there. I don't have policy in place. I don't have MTLS in place or anything like that. Okay, so we're going to deploy a routing policy. Okay, before I do, you may have noticed that there's a Gateway API tab here as well. I mean, if you really want to, you can sit there and look at the comparison in configuration of how an HTTP route for the Gateway API services is created. But we're sticking with the Ingress Gateway primarily because if you're on the exam, you're unlikely going to see Gateway APIs show up as configurations. It's likely that you're just going to be dealing with Istio Ingress Gateway and the Istio resources that exist here. So let's go ahead and apply all of this. All it's doing is saying, here's the HTTP bin app. We are sending it to version 1, and we're sending 100% of our traffic to version 1. But our destination rule has defined 2 different versions for the HTTP bin app. So even though we might be going to this host, our routing rule is telling us which specific pod we're going to. So that's been deployed. We're now going to just quickly create an environment variable for the sleep pod, because I don't want to be doing the exec into the pod every single time by its full name. So we have that as an environment variable. Sorry, was there a comment, question, thought?
Yeah, you could actually do, I think you could do kubectl exec deploy,
And the
I
name of the
think,
deployment,
and then it's gonna pick the pod, I think.
That's a good point too.
Yeah.
That would work as well. To keep things simple, we'll just use this for now. But if you look at this curl command, I have my camera blocking it. But we're execing into the sleep pod, or whatever the name of it is, and we're just going to the sleep container, because notice there are 2 out of 2 containers there. We wouldn't want to miss this flag here, because it might go to the Istio proxy instead. And we're just issuing a curl to HTTP bin on port 8000 with the headers path. And we get a response as we expect to. So we know that going to version 1 works just fine from the sleep pod. Now, the reality is I haven't set up any sort of mirroring yet. So I also haven't configured these. Let me just configure these environment variables. I don't know why I had to do this previously, but I think it just makes it easier for getting through the module. So you don't have to type out the container name as well. Same deal as before. If you notice, that previous curl that I did from the sleep pod was recorded here, was logged here. So we know that this this HTTP bin v1 is getting it. But if we do the same thing over here, it's not going to display any logs, because we haven't mirrored any traffic. We actually haven't sent any traffic to v2. So that makes sense. I mean, that makes complete sense. My routing configuration doesn't even say to go to v2. It just says to go to v1. So we'll come back and take a look at the logs the moment I update the routing configuration and rerun some curls from the sleep pod over to HTTP bin. So in this configuration here, let's take a quick peek. It's the same virtual service config, but even though I'm routing all my requests to version 1, I have this mirror entry here, which basically says I'm going to mirror my traffic to the secondary subset, or version 2. Oops, shoot. Damn, this is why I shouldn't do these things. Okay, and it sends 100%, or it mirrors 100% of that traffic to v2. So what should happen is, when I reissue those curl commands like I did above here somewhere, here, I should see log entries for v2, or v2's pod, which I didn't see before. So let's go ahead and apply this. Now, you might be wondering, if I'm sending requests to v1 and I'm mirroring those requests to v2, what actually happens to those responses for v2? Peter, you want to answer that?
Well, they're just fired off, and
Exactly.
they go to digital heaven. The responses.
Exactly. So it's wormholed. It just goes nowhere at this point, right? So, all right. So we have the configuration there. You can just up arrow a bit somewhere. I shouldn't be doing up arrow like this, but. So I ran another curl, and if I go look for the history again, or the logs. Actually, let's run another curl here. Okay, so now we see that the curls went through to version 1. We should also see that the curls go to version 2. And that's how we mirror our traffic. So it's easy enough to configure the mirroring of your traffic. I'll be very real about something. When it comes to the exam, it's probably not going to be a simple copy and paste. They might have some specific parameters where they want you to send like 75% of your traffic to, or mirror only 75% of your traffic to v2 or something like that. They might throw out some specific parameters. And what it really comes down to is just making sure that your indentation stays the same as you copy this over and making the necessary changes. That's probably all you would have to focus on. Okay, so that takes care of that. So we've seen some traffic mirroring. We're 45 minutes in. We've seen some traffic routing, some request routing. I'm going to take a quick break. Peter, if you want to add some color.
Yeah. Do you want me to continue with one of the topics or anything specifically?
Yeah, maybe discuss some of the use cases around maybe the egress gateway and even.
Oh, I know. I can show that subset thing that I was talking about
go for
the past 2 days.
Exactly. So I'm just going to run off to the washroom. Sorry, y'all.
No worries.
I'll be back in a
Let
second.
me just share my screen really quickly here, and I'll show that thing that I was talking about. All right. I don't need this mirroring here, so let me just do full screen, make the font bigger. I don't have anything deployed. I have a clean cluster with Istio 119. So what I want to do is I actually want to deploy. Let's just do HTTP bin, and we'll deploy that one. I'm just looking for a URL. There we go. So we'll apply HTTP bin. Oh, what did I miss? Oh, that's not a right URL. It has to be raw, right? There you go. Raw. This guy. Okay. This one. All right. So we have HTTP bin. So let's just double check. It's still running initializing. It might take a little bit longer because I'm actually using a real cluster here, not a local one. Okay, it's already deployed. Perfect. And then what I'll do is I'll just define. Actually, let's look at the configuration really quickly. So if we do istio-ctl proxy config, sorry, I have to do this. Istio-ctl proxy config or PC, and we want to look at the clusters, the Envoy clusters in this case, not to be mistaken by the Kubernetes clusters. And I'm going to paste in the HTTP bin pod name, right? So what this will do is this will give us the clusters configuration that's in the sidecar proxy that runs next to the HTTP bin pod. So let's do this. And you'll notice these are all the clusters that specific proxy knows about, right? So it knows about itself, egress gateway, ingress gateway, IstioD, kubedns, Kubernetes, etc., right? And then there's that black hole cluster. There's that pass-through cluster that I was talking about yesterday as well, right? But the thing is here, right? So there's a cluster here with this name, HTTP bin default service cluster local. Actually, that's the service fully qualified domain name. That's not the actual cluster name. And the port 8000. And notice there's a column here called subset, right? And it's empty because we don't have any subsets. Now, if we look at the actual JSON representation, and I'll just grep for HTTP bin. I know I'll probably going to be a lot of text here, but let's do this. And let's see if I can find it. This is the actual name of the cluster, right? So notice all those columns, so port, subset, direction, right? All those columns are actually, the values from those columns are part of the actual Envoy cluster name, right? So the direction, which is outbound, port is 8000. And notice there's two empty pipes here. There's nothing in here. That's where the subset would go, right? And then we have the fully qualified service name, right? So let's see what happens if we deploy a destination rule. Destination rule. And I'm just using this to do a copy paste here. And let me, I really don't want to use Vim, but I'll do that.
It's my favorite tool.
It's like, no, like nothing against it. I'm just not familiar with it. I always say I'm going to learn how to learn some of the like shortcuts, because that's all that matters here pretty much, but I never do. So let's do the full I'll leave this in even though it doesn't matter. The thing that matters here is the subset. So I'll say my first subset, just so we can see it clearly, and version v1, it doesn't really matter. And the name, my blah subset, whatever. Labels, whoops. Need to delete this, and then we can do labels. And I know we were always doing like version, but this could be like environment, right? It doesn't have to be version. It could be whatever. And I'll just do env prod. There you go. So if we save this, and if I apply it, -f dot YAML. All right, so this DR was created. And let's see what happens. Let's look at that same configuration as we did before, right? You already see that there's more stuff than there was before. And notice, just make full screen here. There's an HTTP bin here without a subset. There's one with that blah subset that we set up, and there's another one there with my first subset that we also configured. And it's actually also telling you, oh, this is configured by the HTTP bin -dr.default, which is the namespace name, the destination rule with that name in that namespace. So just quickly show this as well. And you'll notice that this time we'll have, notice the name here, right? So this time it's going to be outbound port, name of the subset, and then HTTP bin, blah, 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 right? And if we would look at the actual endpoints for this subset, I mean, in this case, it would be 0 because I haven't deployed any pods with the labels that are defined in this my first subset. But if you would look at the endpoints, the IPs, you would see only the pods that have the labels that are defined in that subset. All right, back to you, Marino.
All right, let me share my screen again. Probably entire screen would be best. So I'm just going to move this over. Okay, so let's get back into it and let's talk about the next section on the exam, which is resiliency and fault injection. So there are 3 key areas that you would definitely need to know about with respect to fault injection. In fact, it really comes down to things you would actually have to configure here. It's 20% on the exam, so it's a good chunk, right? There are key concepts that we'll cover around circuit breakers, using artificial delays, fault injection, and then using things like timeouts to build out some additional resiliency. So let's take a look at that, and we'll go through some tasks in a second. Actually, I should just share my entire. I'm sharing the.
Oh, you are.
Yeah, yeah. It just feels a little small, so I'm gonna just share my window. Here we go. Okay, so in the case of timeouts, there might be instances where we might want to, how would I say this? So we have this request that happens. Service A needs to talk to service B needs to talk to service C. What we can do is we can implement a timeout where we tell service A to wait a certain period of time before it deems the service that's trying to access as inaccessible. So we can build that in as a timeout, just to be able to tell applications to wait, a certain period of time before they have to communicate that another service is down, or before they time out that overall request. So when you think about services, a group of services, there might be a service, let's say service B, for example, that is taking a little bit longer than it needs to be able to provide a response. And that might be because it's servicing multiple requests from multiple different requesters, multiple different services. And so you might just need to build in a buffer to be able to handle that. Now, in the case of retries, one of the things we also want our services to do is not just give up the moment a service call fails. So if service A makes a call to service B, and that call fails, I think by default there's a retry built in. That's correct, right? So there's a default retry that's available that happens. But the thing is, after that, then the service is deemed unavailable. So we can tune this so that we can allow the service to make a couple more retries or a few retries to make sure that we still get that response. Because it could be the same situation where service B is just overloaded. It can't respond to the request quickly enough. And so we want to give it some time. So in this case, right, let's look at this example. I know I'm not using the specific services or the service names, but let's just say service A has to call on service B. And if we look at the specific retries here, we'll make 3 attempts, 3 retries. And what we'll do is we'll ensure that between each retry, we'll wait about 2 seconds before that retry is attempted again. Just in the off chance that service B is able to respond back and say, yep, here's your response. So that is some resiliency you can easily build in. And that's important because we can't just simply assume that all services are going to respond like that on demand, right? There has to be some sort of flow control. So using these retries and timeouts help with that, even delays.
Yeah. So one thing, if you just go back to the previous slide, that maybe I didn't understand correctly or hear you correctly, the per try timeout is just a timeout on how long each retry will wait
exactly
to receive a response. And if it doesn't, in this case, if it doesn't receive a response within 2 seconds, it's just gonna retry again, basically.
Exactly.
Right?
Exactly.
Yeah.
Okay. So fault injections. One of the ways to test out resiliency is by artificially injecting some sort of fault. So we could say we want to inject a 5-second fault to just simulate some sort of latency in the request for an amount of requests. So for example, let's say we send out 10 requests, 10% should have an artificial fault of about 5 seconds. So 1 out of those 10 requests is going to be delayed by 5 seconds, which should tell us a number of things about how service B handles that or how it responds to it accordingly. So based off of that configuration, I mean, we could go pretty elaborate in the way we configure our fault injections, but we're going to see some of that when we actually configure circuit breaking as well. So when we look at circuit breakers, one of the things that circuit breakers really help with is providing the experience of the application, even if it's in a degraded state. So let's take, for example, I don't know, maybe Amazon.com might be a great example where you have all of these different things you can click on. You can go look up something with the search bar and find the product you're looking for, or you can go to the cart and check out whatever you might have added to your basket, or you could just, browse or check out some of their promotions that they're offering up. But the way they built it out is each one of those little components is their own little microservice. Let me ask you all, should you actually not be able to access Amazon.com if the search bar is unavailable? I mean, they wouldn't want you to do that. They'd still want you to come to the website so that maybe whatever is showing up on that main page as something that's not needing to be searched up, you can just click on it and then add it to your cart. That should still be able to function, right? That's effectively what circuit breakers are there to do. So in the case of this little scenario, we have service A that needs to talk to service B and over to service C. Service B could become unavailable. That shouldn't mean that the way service A and service C transact and provide their responses should be impacted. I mean, maybe they're not able to provide all the data that you're looking for, but the reality is you'll still get some response or a partial response or a degraded response. So one of the ways we can tune this in Istio is basically configuring our destination rule to basically look at a few things, right? So we can look at something called a connection pool, which basically is targeting a service to have no more than a certain amount of TCP-based connections or HTTP-based connections. And based off of those connections, how many requests can be fed in through those connections. So if you think about it, if you've overloaded the max amount of connections, a single TCP connection, at that point, any further TCP communication towards that service B for this matter, might be denied or rejected or just not allowed. But in the case of, let's say, we have service B that just simply doesn't respond after meeting those connection thresholds, One thing that we'll do is we'll scan and see how many 5xx errors we get. We can even tune this. We could say every second we'll scan to see how many 5xx errors we're getting. If we're getting 2 in a given 1 second period, that's problematic for us, or 1 for that matter. What that tells us is we can make and tell the rest of the mesh or the rest of the services in the mesh that service B is going to be unavailable for 3 minutes in this case. Now, if it's unavailable for 3 minutes, what happens if it has 5 copies of it? So if we have 5 copies and we see that little field there, max ejection percent 100, we would effectively want to ensure all 5 of those copies are ejected in the service path altogether, and they're not actually touched in that service request path, meaning they're just not available and they're not accessible. Anything you want to add to that, Peter or Alessandro?
So max ejection, like if you let's say you have 5 instances, right? 5 replicas running, and you get more than one consecutive 5xx error from one of the instances, right? Whichever that instance is, that one's going to get ejected, right, for 3 minutes. So the next request, whether it be at a retry or whatever it is going to go to a different endpoint. And then if that one gets a 500, that one's going to get ejected, right? And the max ejection percent just means that all of them will be ejected eventually if all of them fail. However, you could theoretically set this to, let's say, 50%, right? And then only eject like 2 of those 4 pods, even though the remaining 2 might be failing as well. You just don't want to eject them necessarily, right? Mm-hmm. The idea with the circuit breaker is basically just it's in a way it's guarding for like unnecessary downstream pressure, right? Because your services might get overloaded, right? Like if you make a call to a service once, twice, 3 times and it returns a 500 error, it's not going to magically come back after a 4th or 5th retry, right? So
exactly.
It's like, why create that pressure and everything? Let's just eject that one out, and maybe we get lucky with a different instance, and that one will go through.
So having max eject less than 100 effectively implements a rate limiting on the request on the downstream service?
No, not really, right? It's just like if you have the max, let's say you have 10 pods, right? And you say max ejection is 100%, and you make 1,000 calls or whatever it is, right? And if you think requests will go to each one of those host endpoints at some point, right? And let's assume all of them return a 500, all of them will be ejected for 3 minutes, right? So if everything happens within a span of 1 minute, if we fire off that many requests, you basically won't have any, and I'm doing air quotes here, healthy endpoint running, right? You have 0 hosts, right? Your load balancer will have 0 endpoints, right? To load balance across. So that's 100%. If you do 50, you'll be left with 50 pods or 5 pods. I don't remember how many we said, right? But half of it what you had. And you could still send requests, and those requests might still be failing, but you're not going to eject all pods out of it, right? So it's just a way if you want to keep like a set of pods always running no matter what, even if they're failing, right? Because there might be a failure on a specific endpoint only, right? You don't know, right? Let's say you have the review service and you have 5 different endpoints exposed through that. Like by endpoint, I mean slash send reviews, slash get reviews, slash update reviews, right? And your API exposes those. If slash send reviews is failing on all the 5 instances or 10 instances, you don't necessarily want to eject all of it, right? Because maybe the get reviews is still working, right? So maybe you have a failure only on specific endpoints, right? So it's always good to keep some percentage running, right? And not just eject everything, unless, I mean, who am I to tell you what you can do or not? But typically, right? Unless you only have like one one method, one function in the API that you're exposing, right? In that case, it doesn't really matter, right? Because nothing else might succeed anyway, right? Yeah, I feel like I overcomplicated this.
No, I think you're good. It always helps have a different perspective of using circuit breakers. So having said that, this is a great segue into us getting into the demo side of things. So let me reshare my screen and share my entire screen. All right, let me go over to this tab over here under the resiliency. So yeah, if you really want to go read a little bit more about how the resiliency features works inside of Service Mesh or Istio specifically, I'll just drop the link here in our chat here. So feel free to go take a look at that. Also, just have these links handy as bookmarks. I imagine if this exam is anything like the CKA, then you should be able to just drop your bookmark folder down and then click on the specific link instead of having to go search it. I think it's helpful. The ones that we've showed you so far, definitely go spend the time to bookmark them. Okay, so let's do the fault injection section first. So we've got Istio already installed, book info is deployed. We're going to deploy this service YAML, or sorry, the virtual service YAML, as well as a reviews YAML. But I want to see what that reviews YAML is because I'm not sure what's inside of it. Maybe I do. I don't know, but let's just cat it and see what's going on. All right. Yeah, nothing special. It's just an updated review service that has, or virtual service that just has the HTTP header matched there. So it'll just route it to V2, which is exactly what we expect. Now, what it's saying here with the above configuration, this is how the request flows. So you hit product page if you're going to reviews V2, and then you'll get ratings, but only for the JSON user. Everyone else gets V1 and doesn't get ratings, which is interesting. So we're going to inject an HTTP delay fault. So let's take a look at this. Arrow A, we're going to remove all of this and just cap this quickly. Okay. So this is our virtual service resource. And if we match on JSON or JSON, I keep saying JSON as an existing header user, we're going to artificially inject a fault of a fixed delay of 7 seconds for 100% of those requests. So, and then we'll route to, V1. And then otherwise, if you're not JSON, you're going to route to V1. So we're actually going to just see a delay if we log in as JSON. If we don't log in as JSON, we should automatically see the page load like instantaneously. So let's go ahead and deploy that.
Did you mean Jason or Jason?
Jason, JAS. I know I'm struggling with the naming. I'm gonna go file some PRs and have them change it to Jason.
Change this, yeah. You're gonna break probably a bunch of examples and demos and whatnot.
Just try and search for every reference of Jason. Control find.
Yeah, replace. Yeah.
Okay. Let's just. I know it's created, but it's probably gonna scream if it doesn't have it here. But yeah, it's there, so it's good to go. So if we go into the product page, I'm just going to close off this tab, and I'm just going to refresh. And yeah, I mean, I'm able to get to the reviews service, but I'm only going to reviews V1, which is expected. So what I'm going to also do is I'm going to just open up an incognito window here, just so that I have no cache cleared, all my cache cleared. And I'm just going to go back to that website art page, and then I'm going to sign in as Jason. So it took a bit of time to get to that. It took 7 seconds to get there. Well, it actually took less, but
well, you could always do a curl, right, from the command line to the exact same thing, and just use the dash H, right?
And then JSON, right? Yeah.
Yeah, end dash H, and then in the quotes end user dash user colon JSON, right? And that's gonna simulate the same
Exactly.
thing. Yeah.
So 127.
And it might be easier to see here in the command line, right?
So as long as this thing's up. Oh yeah, that thing's been blocking it. Wait, why did that go through so quickly?
We're gonna, let's see.
Curl-h end user JSON product page. That should have taken 7 seconds. Is there like a specific? I'm probably missing one other parameter here, right?
No, let me look at the link that you posted. This one, right?
Yeah.
Okay. Latest docs, concepts, traffic management, and then network resilience, fault injection, right?
Yeah.
So, oh, was it fault injection on the ratings? Oh yeah, I think. So what you would have to do is you would have to call the ratings service directly, not through the product.
Oh yeah.
Page,
Okay.
right, because you from that configuration, the ratings, it's the ratings host where that fault is. But it's weird because I'm assuming this product page would, or maybe it doesn't make a call directly to the ratings service, right?
Mess around and experiment quickly for a second. Oh, that didn't work. Dash H.
I don't remember exactly how no, you would probably, I don't know, is it exposed? Do you have it exposed publicly?
No, I mean, well, technically.
Oh, the slash ratings is exposed. Is it exposed through the ingress gateway?
I don't think so, actually. If I do
probably not. So probably that one is returning an error, right?
Nothing, yeah.
But yeah, the other reason this, even if it might be exposed, the reason if it's not working, if you call it directly, is because your host is 127.0.0.1. It's not.
Exactly, yeah.
It's not ratings, right, or whatever, reviews, right? It was reviews, or no, it was ratings, right?
Yeah.
But it should work in the browser, right? In the browser, you should see the delay.
Yeah, and we did. I mean, like.
Yeah. And I sorry, product reviews are currently unavailable. That's the error, right?
Exactly. So it's working as intended. It's just on the.
Oh yeah, and I think if you open the developer tab,
tools, yeah,
it's going to actually show. You can actually see that how long it's.
So if you go to the developer tools under the network tab, you can see it takes. If I refresh it, it'll show.
Yeah, refresh. Yeah. Yeah, there you go. See, it's still pending, right?
Yeah.
So
it takes
6 seconds, right?
Yeah, literally under 7 seconds. Yeah. But there is that delay that we expect to see based off of what we fed in, based off of that user information. So we know that the delay is working as expected. Just don't know the right command line or the curl to run it against.
Yeah. I don't know why it should be failing, to be completely honest. I mean, not failing, should be taking longer. Yeah.
So there's another section here about injecting an HTTP abort fault. I'll get to that in a second. But what it's telling us is to fix the bug, you can either increase the product page to review service timeout or decrease the reviews to rating service timeout. We could stop and restart the fixed microservice, and we can confirm that the product page returns a response without any errors. However, you already have a fix running in V3 of the review service. If you migrate all traffic to V3, then yeah, I mean, basically that should resolve that issue. But We don't need to do that for this particular module. So injecting an HTTP abort fault. So it says another way to test microservice resiliency is to reduce or introduce an HTTP abort fault. So we'll introduce an abort to the ratings microservice for the test user JSON. So, maybe you can explain this abort fault configuration and what this is supposed to do.
Yeah, I mean it's same as very very similar as the delays, right? So instead of just waiting for that specified amount of time, what this will do is it will, in this case, in this example, just return an HTTP 500 for 100% of the requests that reach the rating service when the
matches
end user header matches
JSON.
JSON.
Okay.
Yeah.
So it's called out here under the HTTP
Yes.
configuration where it returns the 500 status.
Yeah.
Okay. So it's in there, and we can even just test it here. So if I go back to that hidden or that incognito window, sign out and then sign back in as JSON. It says rating service is currently unavailable. Is that what we were expecting to see?
Yeah, and I think and if you look at the network tab, you should see. I think you should see a 500 there, right? I have to refresh. Maybe not. Oh, because it's not a. It's a downstream service, right? So the product page actually returns 200, right? But the
downstream service will return
whatever the rating service that gets called by the product service returns a.
So technically, I could curl from the product page with the JSON header flag.
So what you could do if we really want to test this, you could go into, like, if you have a sleep pod, from within the sleep pod, you could execute a curl request against the ratings service. Right. I just don't know what ratings was. V3. Was it a specific version? No.
It was V1.
V1. So just ratings, right? Just ratings. If you would, like, if you have, I don't know if you have, you don't have you have a sleep pod. Yeah. So if you do kubectl exec sleep. And then in the meantime, I'll take a look what the actual endpoint is on the reviews, right? And then you do curl reviews.
So curl dash capital H end user HTTP. And then
rating. Was it rating? Ratings, yeah. No, it's ratings, right? Yeah.
One.
Oh, no. Just the service. It's the service. Service is versionless. Yeah. Kubernetes service, right? Yeah. I don't know why is it taking so long, but we'll see.
It should. Remember?
It should. Well, do you still have sleeve? But it should. Didn't you apply the abort?
Oh yeah, I applied the abort. That's right.
But it is. I mean, it's failing, right? That's if you do -v on curl, you should probably see what the error is. Just don't know why it takes so long. But it looks.
Okay, so let's try one last thing. I'm going to actually remove the -h and the end user JSON and see how this works.
Something might be off in your. Yeah, that's odd. I don't know why it's doing a 503.
Can you look at the envoy logs?
I would say it's something with the, but it's working from the from the web, right? From the browser.
It's doing exactly. It's just the way we're calling it is maybe the issue. Actually, let me check something.
Oh, it's 9080. It's the port, right? It's not 80, right? That's why probably, yeah, colon 9080.
There you go.
Okay, so this is 404, but it's why is it doing not found? And then if you do with the header, I mean, at least we can verify that one, right? That one should be 500 now, right? Is it?
Server. So that
Yeah, it's 500, right? Even though maybe our like URL endpoint is not correct. Oh, let's just make it proper. Just run the first command again, the first curl, and just do /reviews/ oh, that's fine. After ratings. No, that's fine. 9080 / there you go. Ratings /1, I guess, the ID. This should work, right? Yeah, there you go, right? So it returns the actual rating and review. So, and then if you do it with the header, it's gonna do a 500. So, but yeah, that's what it was. It was port. It's not always 80. And this is one of the things that can happen on the exam as well, right? Where you might think it's port 80 or assume, but it's really not.
So for the folks watching this, like literally, this is important to probably just keep in the back of your head. If you're trying to troubleshoot something, this curl command might come in handy. Deploy that sleep pod similarly to what we did, and that might help. I mean, the website tells us one thing, but who knows? Maybe the exam is going to ask you to output the contents of this curl to a file. So, and not saying that actually could happen. I'm just saying that because I've seen something like that in the CKA.
Okay.
Right. I could expect. Yeah. So it's always handy to have this. And if you're trying to output that to a file, just use the double I forgot what it's called.
That thing.
Yeah, that thing. One that points away from the
yeah.
outwards, and then routing your file, right? Or whatever you want to call it, like test.conf or something like that.
Yeah.
And if you do an a cat test.conf, oh shit, that didn't work.
Yeah, no, that's fine. That's fine. It worked, right? That's the thing that I wanted to bring up. Before, can you rerun the curl without going to the file?
Yeah.
Just like without those two things. Yeah. Notice we got a 500, but then also before that line, if you go, see it says fault filter abort, right?
Yeah.
This is telling you that this is the message, the body, right, of the response that Envoy adds, basically telling you, oh, someone configured this fault filter, right?
Yeah.
And that's why you had that in the file, because that was the body of the response.
The thing is, the only thing it had was just this. It didn't have anything else.
Well, because it's body, right? You're piping the request response, I guess. I don't know how you do. There's a way to do the whole thing.
Yeah.
Probably.
Yeah, there might be a way. I mean, for y'all, maybe spend some time looking out.
The other option is open an editor, select copy paste, and that's it, and you're done. It's the same thing.
Look, and folks, I'm not saying that this is going to be on the exam. It's just, I have some trauma from previous exams. So, all right, okay, we're done with the. I think we're done with the fault injection task. So let's get this cleaned up because we've got maybe about 20-25 minutes left. So I'm going to go ahead and delete the configuration, but just to recap that fault injection, we're basically injecting a delay, or we're using the abort configuration based off of the header match, right? That's the key there, right? I mean, the fault abort is the other configuration that allows you to do so, but the delay up here, when you use the fault delay, fixed delay configuration, you can align this with a user header. I mean, you could do a number of things as well. In fact, if you go to the virtual services resource under configuration in the Istio docs, I think it's because my window's not wide enough, but I'll point to it towards the end. You'll see that there's so many other fields and flags that you actually have to consider in terms of how you would configure your virtual service. In fact, you know what? Let's just go there. While I am here. So this is what I was talking about. Okay, just something to note. Peter and I were sitting here working through regex last week, trying to get this sorted for something around log4shell. So it can get pretty advanced, but you can imagine if you come in here and you look at all the different configurational fields, get familiar with them. I'm not saying that you're going to have to configure all of this for the exam, but we don't know what the heck's going to show up on the exam, right? So it's worth like digging into using a TCP route versus an HTTP route, or having both show up in your virtual service config. So, all right, let's continue on into requests. No, I did fault injection. I'll do circuit breaking last. Request timeouts. Okay, so let's do request timeouts here. And as I mentioned before, we're basically saying we're going to inject a fault here, and we're going to adjust how we recover from that fault with some timeouts of our requests. So the first thing I'm going to do is I'm going to deploy my virtual service configuration again. I have a VS configured, and everything by the looks of it is going to go to V1. Now I'm going to create a new virtual service configuration for V2, right? And if you look here, it's calling out on a subset, a specific subset V2. So the destination rule will have that subset translation. And now we're going to go and update that virtual service config again. We're going to update the ratings one and add that fixed delay of 2 seconds for 100% of our requests. So again, it's under the HTTP section. You add the fault first that you want, and it's going to match to the specific route for this destination, which is just version 1 of the ratings. Remember, the subset has a definition inside of that destination rule file. So if I open up the product, I can't do this. I have to actually use the URL. So if I go to HTTP, product page, it's taking some time, but it actually loaded after about 2 seconds. So it took 2 seconds. It actually honored the 2 seconds that I configured there. And now we know that that delay is effective. But we want to fix this. We want to adjust this. Where's my tab? There it is. Okay. So we're able to add that delay. What we want to do now is we actually want to add a timeout to that request. So what this half-second timeout is going to do is that it's going to allow us to return our web page in less than 2 seconds. But the reason it actually calls it out here is because we actually have a hard-coded retry in product page. So it'll actually call out for the review service twice before it actually has to time out. So if we apply this, we'll see how quickly it actually loads. If I go back here, that's 1 second. Takes about 1 second for it to load. So there's really like, all we're really doing here is we're just affecting the way we would access our service and adding artificial timeouts and delays here just to effectively give it some buffer, give the service some buffer to respond if, for example, it might be overloaded. Peter, anything you want to add to that?
Yeah, this one, I mean, this specific example is just setting it up in such a way that you know that the actual requests, retries were kicked in, right?
Exactly.
And that the overall call was taking longer. That's why we injected the delay, right? And we artificially lowered the timeout version, so it's going to time out, right? And the reason it like says over there that it's twice, right? It retries it twice, is even though we haven't set the number of retries anywhere, right? By default, Istio has 2 retries configured for all of the services, right? That are in the mesh. So that's your default. You don't have to change anything. But if you want to do more retries, you can configure those as well, right? But this was just more of a setup to showcase how it works, right?
Exactly.
Yeah. And the best way, if you're gonna if you're gonna play with this, if you're gonna play with delays and aborts, is install Prometheus, install Grafana. These are fairly easy to spot in Grafana, right? Especially the delays, right, and faults, right? those are very very easy to spot there.
Yeah, I would also go on to add Kiali into that mix as well.
Yeah,
because it helps you visualize like traffic in real time.
Oh, that's true. Yeah, Kiali would actually even show you the it's now red. It used to be green, right? But
yeah.
but the delays are very easy. You can, I think Kiali can connect to Grafana. Let me go back. It's not connecting to Grafana. It does have its own dashboard, right? It has its own graphs, if I remember correctly. So, yep.
Excellent. Yeah, perfect. So we're going to do our very last demo here with circuit breaking. So what we're going to do is we're going to deploy a sample HTTP bin app. And because we've already labeled the namespace, I don't have to run that second command to inject the sidecar. Automatic sidecar injection will occur. So once I deploy this, we'll deploy a circuit breaker. Oh, what is it saying?
What are you missing?
Warning, resources services is missing the kubectl.
Just do I don't know. It's probably there.
Yeah, I ran this earlier, so I don't know what is.
I don't know why. No, it's deployed, right? It's there.
Yeah, I'm not worried. Okay, so we're going to create a destination rule. Now, this is heavy. So this is kind of what we talked about much earlier on. But this destination rule is basically going to look at the request coming inbound. And if we're overloaded on requests, we may consider ejecting the actual service so it's not in path or available to be responding to requests anymore. So we'll take a look at it. We know it's there, so I don't have to go and verify, but I don't know, just for fun, let's make sure that Kubernetes actually honored that configuration. So it's there, it's good. So we're going to add something called a Fortio client, and it's just basically going to allow us to test out the circuit breaking functionality. So nothing special. If you really want to go and see what the deployment looks like, I mean, you're welcome to. But we'll exec into the pod, and we're just going to run some curls towards the actual HTTP bin service. And we're actually going to see.
Fortio will be making, right? Fortio will be.
Yeah, Fortio is the one that's making the request to the HTTP bin service. So I have to just exec into it.
Yeah, because it can do like concurrent requests, and
exactly
you can't actually simulate this on your own easily.
Well, yeah, and the point of the concurrent requests is so that we can demonstrate that the service can't handle based off of that connection pool settings right here. So if we had like 5 concurrent requests and this is limited to 1, what do we expect to happen?
Yeah.
Right.
Yeah.
So thanks for bringing that up. All right. So let's trip that circuit breaker. We sent 1 request over, but here's where we're going to send the 2 concurrent requests, which is this -C 2. So
we'll send 20 requests, right? With 2 connections. Yeah.
Exactly. And this should definitely trip the circuit breaker, which it did. So where's the trip message?
Oh, you can see the code 503 at the bottom, basically, right? There's code. 70% of the calls went through.
Yeah, right here. Okay, this is exactly what I was looking for.
Yeah.
So 14 of those 20 requests were successful. 6 of them no, because I think we just overloaded the service based off of those parameters up there. So if we change this concurrent connections to 3 and then have 30 requests go through, we'll see a different split as expeced.
Yeah.
And so you'll know
should be even worse. Yeah.
So 20 of our requests made it through, while 10 of them just did not. They were not happy at all. So the circuit breaker is functioning as we expect it to. Let's take a look at the Istio proxy and see what it's telling us. So you can always query the Istio proxy because it's very resourceful to understand what might be going on from a log standpoint, or even connections inbound or outbound. But if we see here, I think it's the overflow request that we're looking for, which is telling us that, so it's telling us that 21 calls in this case, but in our case, we have 16 calls that flagged it for circuit breaking because they were over the threshold.
Mm-hmm. Yeah.
So we know that circuit breaker is working in this particular instance. I don't know, Peter, do you want to add any additional color there?
No, I mean, it's one thing on the metrics from like the Istio proxy. I don't know exactly why they're using this pilot agent request get stats thing, because you could just easily do curl to localhost 15,000 / stats and get the same thing, right?
Let's do that. Let's run the command.
Yeah, I don't know. Maybe it was a leftover. Maybe this is an older, but yeah, it's localhost 15,000. I think it's just slash stats. That should give you all the stats that the
okay.
Right, and then you do just grep for the however, what you can do is you can do I think it's prom /stats or /stats /prom. I don't remember exactly. Let me see. No, this one will actually tell you stats. Where was stats? Stats /stats /Prometheus. That one will give you that nice format. So I was wrong. /stats /Prometheus.
Oh wow, okay.
Yeah, and this one gives you the not. I mean, it's debatable if this is nicer than the previous one because there's so many things here. But you would have to grep for pending, right? And you would see the same. I think you would see the same numbers there.
Yeah, I'd have to.
I mean, you can already see. I can already see 16 there somewhere in one of those. So I'm assuming that's the same one that we saw. Yeah, there's 35. There's 16, right?
Yeah, there you go.
So yeah, so it's all there.
Yeah. So exactly, this is how you would run through a circuit breaker exercise. Obviously, for production use cases, you have to sit there and think like. First, you don't want to implement circuit breakers without knowing how your services are operating. So I always feel like, and that's why I mentioned Kiali is a great tool to really baseline how your services are communicating, and then you can tie that to other tools like Prometheus and Grafana and just create some heuristic information. And then based off of that is where you decide how you want to architect your circuit breakers, injections, and fault delays.
Yeah, there's always, I think there's always time when you, or period, I guess, where you'll have to fine tune all these settings, right? Because you don't want to be too aggressive with these and, or not aggressive enough with some of them, right? Things like fault injection, right? That's more of a testing thing, right? You could think of just randomly injecting faults into fleet of your services and then observing how they behave, right? More use it as a testing tool. But circuit breakers, yeah, definitely a fine tune it, make sure it works for you so it's not too aggressive or not aggressive enough, I guess.
Exactly. Yeah. So that brings us to the end of that demo. I think we've seen a number of different capabilities within Istio itself in terms of what it can do. I'm just going to remove all my resources, but I just wanted to point out something. So I ran a CD all the way into book info into the networking folder here because all the different configurations I used to demonstrate some of the book info functionality is located here. I didn't have to source it anywhere else. Once you pull down the Istio installation binary, it actually is packaged with a whole bunch of this stuff as well. So you can run everything you need to within this directory. But I'd also implore all of you to just go take a look at these configurations, understand them, understand the linkage, understand where you would configure your faults or your delays, or where you would throw in like header information. Especially like in the exam, you don't know what they're going to ask you. So you familiarizing yourself with how the YAML is structured is probably going to be very critical, and knowing where all this stuff is in the documentation.
Yeah. I think those are like the top level things that I would want to learn and know, I guess, where to find, know how to learn how to Google, I guess. It boils down to know how to find the information on Istio.io. But I mean, you're not going to be, don't think you're going to make the exam without actually going through these exams. You probably won't, right? There's not 2 hours sounds a lot of time, but it's really not a lot of time. And if you have to go and look up all of these things, it's gonna take, without knowing where stuff is and how stuff works. It's not gonna be. It's not gonna end up well, I guess. At least that your exam try is not gonna end up well. But
exactly. So on that note, right? If you go to the configuration section and go specifically, let's say we pick up the virtual service config. I mentioned that there are a whole bunch of fields that you can configure and tune. I highly recommend you all familiarize yourself with as many of these fields as you possibly can, especially like things like doing TLS route or TCP route or HTTP match request or basically anything here. The rewrite even. I mean, we don't know what will show up, so it's always expected. It seems like there is some advanced stuff here. But I think if you're able to piece together where these things go, and then you go back and you look at the question, what it's asking for, you'll be able to form your own YAML structure as well. There might even be an example somewhere hidden on this website if you do a
there definitely are examples. But one thing that I would do if I was taking the exam, I would try to remember on which website or which page on Istio.io I should go to just get like a bare bones virtual service resource. That's it, because theoretically you don't need anything else, and no one is expecting you to type up these resources from zero, right?
Exactly.
Go copy this one,
exactly.
modify it, make sure you modify it correctly, right? The other option that you could do is, if there are already VS or destination rule resources applied on the cluster, just get them from there, right? It's -o YAML, grab that YAML that's already applied and use that as your like as your starting point, as your template, whatever, right? But I wouldn't necessarily learn. I mean, try to remember all the, all match, and then this is the order of the. As long as you understand, right? Like, there might be a question that says route traffic here for 50% and 50% there to that subset, right? There might be a question of forward the traffic to that URL or that service, or we want to match on this URL, but then we want to rewrite something to a different URL, right? And those keywords like rewrite, redirect, right? Think about match, right? Those are all specific things that those are the features that you should know about, right? Knowing that those exist, looking them up is fairly straightforward at that point, right?
Exactly, yeah. And all this entire page has a bunch of examples that allow you to easily pull from. So if you are good at navigating this site, you will have a good time on the exam, in my opinion. There was one more thing I was going to show, the destination rules and its configurable parameters, because this is where the magic is when it comes to like resiliency as well. So it always is worth coming in here, seeing how destination rules are configured. And there's like, for example, here's TLS in the destination rule configuration and all the different, like here, for example, the connection pool settings for when we're having to configure circuit breakers, all the different fields or the subfields that you can configure, right? I'll be like honest, they're going to throw in keywords in that ask or in that question. And you probably like, as long as you kind of like look at this, maybe glance at it for a minute or two and go through all of them. And then, like you'll be in the exam. You'll be like, oh wait, I remember that. I remember seeing that. Right? That's all it is.
Yeah, it's either going to be, I'm thinking it's either they're going to throw out an actual field name, right? And they'll say something like, set the connect timeout to blah, right?
Right.
Or they might put it into like words. Not that those are not words, but describe it, like, we want to limit the maximum duration of a connection, right,
Yeah.
to this milliseconds or whatever it is, right? And then you would have to know that this is the max connection duration field that you have to set in the destination rule, right? So a lot of stuff I think comes down to knowing where to find things and then being double checking everything, right? Read the question again, make sure that you read it correctly. Don't assume, because you will probably be under stress, and it's not a pleasant experience, I think, taking a certification or an exam, right? It's stressful. And then double check everything, right? Double check that you don't have a typo, right? Because sometimes it's stupid little things like that that you're just going to get 0 points because you made a typo somewhere, right?
So
And you think it works fine, right? But it doesn't.
exactly. I agree. I mean, along those lines of typos, even the names of your resources that you build. So say, for example, you have to build a destination rule and it asks you to call it book info ratings, but you decide, I'm going to call it book info rate. You know what's going to happen? They have a script that runs, I'm fairly certain that runs to check and see if the resource is aligned to that script. For example, it will match on the name. And if that name is not there, that could be an automatic 0 on that question. Obviously, I think they're a little bit lenient and they'll go back in and see that you messed up the name and had the entire configuration correct. I'm not sure what their scoring guidelines are, but if I were, scoring, I'd probably overlook that one little detail or something.
Yeah. If they, that's what I would suggest. If they explicitly say create a resource with this name created with that name. If they don't, I mean, it's fair game, right? Create it whatever you want. But if they're very explicit, be very follow it directly, right? Follow the thing.
Yeah. Also, there's multiple ways to achieve the same thing. And what I mean by that is I can't imagine there's a million ways to do the same thing for Istio, but if someone's telling you to get output, like I was trying to show earlier on, that didn't really work out the way I was expecting to. Some people automatically assume it could be a JSON output. Like you have to run a JSON query to get that output. There are other ways to get that output and then copy and paste into that text file. So it's things like this that maybe could save you time. Just being really good at working with Linux could help massively. Yeah. But yeah, that's all I've got. Peter, thoughts? Should we close?
No, I think we went for a long time. So yeah, let's call it done for today, and then we'll be back tomorrow. Note that tomorrow we're doing it 1 hour earlier. So instead of 9 a.m., we're doing 9 a.m. PST. We're doing 8 a.m. PST and 11 EST, right? 11 a.m. EST, right?
Yep.
But yeah, and we'll talk about security. So, all right. Thanks, everyone, and we'll see you tomorrow.
Take care, everyone. Bye.
Bye.